Hello, everyone. Welcome to Homework 10 R session. Today's new topic is z-tests uh, for um, for hypothesis tests for a proportion. So, um, what we are doing is we are we want to run a test. We want to run a hypothesis test for a proportion. Um, to do that, we are using the z-test. So the idea of hypothesis test for proportion is that we want to determine whether the hypothesized population proportion differs significantly from the observed sample. Um, the word differs significantly from the observed sample may mean whether the population proportion is less than or greater than or not equal to the from the not equal from the null hypothesis. Okay. So usually we define the null hypothesis as P naught, and since we are dealing in proportions, we write some kind of our belief in the population proportion as 0.5, or just define some number there. And then n is just a number of samples. And we use the hypothesized population proportion and the number of samples to calculate the standard deviation. And p hat is the sample proportion. You want to distinguish p naught and p hat, just make sure that the p hat is the result you get from taking samples. And this is just your hypothesize some kind of belief in population. And so you have a p hat from your some kind of survey or sampling, and then using the p hat and p naught and the standard deviation we found from here, we are finding the test statistics. For the other word for test statistics here is kind of z-score. So we are finding the z-score, which will allow us to figure out the p-value. We have already done the CI prop function, I think in last chapter. It takes three parameters: the p hat, the n, which is the number of samples, and the confidence level. Remember that the CI, the confidence interval, is we are adding or subtracting the margin of error to the p hat. Okay, and margin of error is nothing but critical value times standard error, and then these are the rest, the formula for how to find the critical value and then standard error. So the CI prop returns this value. One is p hat minus margin of error, and the other one is p hat plus the margin of error. Okay. So for example, if we run this function, oops. Okay, I did not run the CI prop yet. Okay, run the CI prop. Okay, so this is lower end of the confidence interval, and this is upper end of the confidence interval. Okay, you also learn p-norm, which outputs the probability less than the parameter you input on the first spot. Here we're using this to find out what the p-value is. from our test statistics. This command is actually same as this one. So when we are when you're running for standard normal distribution, which has mean of 0 and then standard deviation of 1, we can just delete or omit this two parameters and then get the result. It's the same. This is the same thing. So if you are just more comfortable with this type of notation or this type of notation, you can pick whatever you're comfortable with. And the z-test function, I think the main topic of this session is this function, z-test.p, which automatically outputs the p-value when we with the inputs of p hat, n, and then p naught, which is the sample proportion and the number of samples and hypothesized population proportion. Okay, and just like I explained previously, it calculates the standard deviation, test statistic, and p-value lower, p-value upper, and then p-value 2. So let's run a sample. So I'm running a z-test.p, open parenthesis 0.46, comma 100, comma 0.5, which means the hypothesized null population proportion is 0.5, and then by sampling 100 samples, I got the result proportion or the sample proportion as 0.46, and I want to determine whether the hypothesized population proportion, which 0.5, differs from the observed sample, which is 0.46. Okay, and I run this one, and it outputs 4 values here. The first one is test statistic, which is so z-score of this value in the standard normal distribution, and this is a p-value. There's 3 p-values. Okay, so how to read the result? So it kind of depends on the hypothesis test you set up. Okay, so there are 3 types. We can set up the hypothesis test as 3 ways, I think. Whether the population proportion is less than equal to the null hypothesis, or greater or not equal to the null hypothesis. So when we define, so this is the null hypothesis, and then this is alternative hypothesis. So a null hypothesis is the p, the population proportion is equal to the hypothesized population proportion, which is here 0.05, and alternative is the population proportion is less than the hypothesized population proportion, which is 0.05. So if we set up our hypothesis test in this way, we look at the p-value lower. If you set up our alternative hypothesis as this way, we look at this value. And then if you set up our alternative hypothesis as this way, not equal to p naught, we look at this value. Okay, you can see that the p-value 2 is actually the multiple, the 2 times of the p-value lore. Okay, so depending on how you set up the alternative hypothesis, the number you should take should be different. Okay, so let's say our significance level is 0.05, and then we are testing with the alternative hypothesis less than p naught. Okay, then our p-value is 0.21, which is greater than the significance level, which is 0.05. And by comparing the p-value and then the significance level, we can determine that since our p-value is greater than significance level, we do not have evidence to reject our null hypothesis, which is the population proportion is equal to the hypothesized population proportion, which is 0.05. What if we run with bigger number of samples, for example, 1,000 samples, in the outputs these three numbers? Let's say our alternative hypothesis is the same, this one. Then you also look at the first, or the p-value lore, which tell us that p-value is 0.0057, which is a lot less smaller, which is a lot smaller than the p-value. Which is a lot smaller than the significance level, that is 0.05. Then the conclusion we can make from this is that we can reject our null hypothesis that the population proportion is 0.05 because our p-value is smaller than the significance level. Okay. The other topic I want to cover is about the sample size. The sample size, to calculate the sample size, we are using the margin of error, our formula, which is the critical value times the standard error. Okay. We can define the critical value as some z star, and then standard error of proportion as the square root of p times 1 minus p divided by n square rooted. Usually we write 1 minus p, sometimes we write this as q. So just for your information. So we define the confidence interval or confidence level, and we calculate the z star. And then this equation is just a rewrite of this formulation, and we are setting this formulation n on the left hand side so that we can get the sample size from this margin of error formulation. Okay, and n will be the sample size that you will need to end up with some result that you inclined to find. Okay. All right. I hope the session was helpful. Thank you very much.